Alright everyone, welcome back to the day 35 of our daily leetcode challenge, and today we have got maximum ascending subarray sum. So let's try to understand the question. In the given question they will be providing us with an array of size n, and it will have certain values. What they want us to find is what is the maximum sum of an ascending subarray. Now what is an ascending subarray? Ascending subarray is nothing but a part of this array in which all the numbers are strictly increasing. We already did a question of strictly increasing in the last day, and in that we saw that when the numbers are strictly increasing, at least meaning they should have any two adjacent values should have a difference of minimum 1 or more than that. In that case they would be strictly increasing. Or you could also imagine all these values, plot them on the y axis, and you should always find an increasing line or increasing slope. For example, if you take a look here, we have 10, 20, 30, 5, 10 and 50. If we try to plot all these values on a y axis, the graph will kind of look like this. We start from 10, then we reached a 20, then again we reached a 30, then all of a sudden we drop to a 5. So up till this point we have a strictly increasing array where all the values are continuously increasing. We got a decrease here, and then again we are going on an increasing fashion, which is we reach 10 and then we reach 50. So here again this subarray right here and this subarray right here that you see are all in a strictly increasing manner, meaning this subarray and this subarray are both on an increasing pattern. Now we need to find which of these two subarray has the maximum sum. If you try to sum all these values, you will get 60 here and 65 here. So that is why the maximum sum that they returned in this case was 65. Let's take a look at the second example. If you try to plot all these values on a graph, you will see that the line keeps on increasing, like 10, 20, 30, 40, 50. If you try to plot all of these values on a y axis, you will see that with each passing value that we iterate, the graph will always go up, meaning it will start from a 10, then it will go to 20, then 30, then 40, then 50, meaning all these values are in an increasing fashion. So we could say this entire subarray, which is nothing but the entire array, we can take the entire array as a subarray, and then we can return this sum. So again the sum in this case is gonna be 150. So this is what they have returned as well, 150 as the maximum sum. If there would have been values further down the line, we could have checked for that, but since all of these are right now in an increasing fashion, we just summed all these. Let's take a look at the third example which they provided. In this case, if you try to plot all these values, you will see that we started from a 12, then we went to 17, it's an increasing fashion, then again all of a sudden we dropped to a 15, then further dropped down to 13, then further dropped down to 10, then we got an increase of 11, then got an increase of 12. Meaning if you take a look at this graph, you see the values existing in this range are in an increasing fashion, and values existing in this range are in increasing fashion. Sort of what I mean is that our answer lies in any these two subarrays. In these two subarrays is what our answer lies in. So if you plot these values, we saw values between 12 and 17 were in an increasing fashion. After that 17, 15, 13 were in a downward fashion, then up all the way till 10, and then from 10 or right all the way to 12 we were in an increasing fashion. So our answer lies between these two subarray, either this one or this one. So here if we sum these values, we get a value of 29 as the sum, and here if we sum these values, we are getting 21 and 12, which is 33. So that is why they are returning 33 in this case, which is the maximum sum. So this is what they want us to do. So this is how the question is working. And so if you try to do this algorithmically, we are gonna try a similar approach like we did in the previous question that we did, which was finding the subarrays which were strictly increasing. So what we can do is we can start all the way from here. We can always start from here, and initially our sum will be nothing but the value which we are currently at, which is the 0th index. So we have a sum value of 0 initially, and since we are talking about maximum sum, so we'll have another variable defined as max sum, which will be initially set to 0, and then this is a value which we are gonna keep on updating whenever we find a bigger sum than this value that we start with. So initially when we are at 0th index, this is what we are starting with, 0, and this is the maximum sum we are starting with, 0. We are at the 0th index, we add this value to the answer so far, so we add 10. So far the maximum sum that we found is 10. We update this maximum sum value from a 0 to a 10, then we move further. Now from any particular value, the values can either go up or the values can either go down, or the values will be same. If the value goes up and the sum changes, if the value goes up, the sum is going to increase. In this case it went up, so we added 20, the sum becomes 30, right? Now since the sum became 30, we'll update this back to a 30. So this was the case if the value goes up, it's in our favor. But what if the value goes down? If it goes further from, in this case we had a 20, but what if we had a 1? So far we saw that on the 0th index we added 10 to our answer, updated the maximum sum to 10. The moment we reach a value which is less than what we currently have added to our score, what we need to do is we need to set all these, whatever we have so far, set back to 0. Just like we emptied the stack in the previous question, whatever we have so far will be set back to 0, and then we have to add this value that we encountered to this. So basically we are doing a fresh start. Whenever we find a value which is lesser than whatever we have, like kind of, it is like not helping us, you could say, in a manner which is not helping us, or which is not in an increasing manner, the value that we just encountered added to the sum, the next value is less than the value that we just encountered, and it's not helping us, it's not going to help us to find the maximum subarray of an increasing, like we see that this is a decreasing manner. So in that case we'll set back all these all this value that we just encountered to a 0. Basically this means we are emptying the stack. Then we'll add this value, new value, to in this value, which is 1, and then update the maximum sum. You'll see that the maximum sum will still be 10, because 1 is less than 10, so it will still be 10, and then proceed from here. Meaning whenever we are at a downward, whenever we find a value from where the downward slope starts, we are gonna set the value, like the value so far added, to 0, and then at whichever point that reduction kind of happened or the downward trend started, we'll add that value, in the hopes that from here on we are going to find an increasing loop, increasing kind of values appearing. But in this case, since we had a 20, in this case we had a 20, we added 10 so far in our answer, and we encountered a 20 which is greater than the value that we just added, so we're going to just add this to our answer. Now so far our total sum that we have obtained is 30. We update the maximum sum. Now it gets updated from a 10 to a 30. Then we encountered a 30 again. Since this is greater than the value that we just encountered, which was 20, so we add that to our value, which is plus 30 again. So it's 60 now. We update the maximum sum, 60. Now comes the downward trend part. Now we encountered a 5. The value that we just added was a 30, and since the value that we just encountered is a less than the value that we just added, meaning we are going on a downward trend. So far if you see, we started from a 0. What values we added in it? We added a 10, then we added a 20, and then we added a 30. So far our total sum is 60, and we are also kind of updating our maximum sum with each addition. Now we came to a 5. So what this means is, all these values that we have added so far are gonna be of no use, since we are now going on a downward trend. All these values that we added so far has to be set down back to 0, which basically means emptying the stack. If you compare it to the previous question that we solved yesterday. Now we are back to 0. We add this value now to this 0, which is 0 plus 5. Now we are at a 5. Why we added 5? In the hopes that now we from 5 onwards will find certain much higher values that we got so far. We set the value, we added 5 to it, update the maximum sum now, which is still gonna be 60, and then from here on move. From 5 onwards we see we found a higher value. Like the value that we just added is 5, is less than the value we just now encountered, which is 10. So we add that, we add 10 now, the value becomes 15. We try to update with our max sum, which is still going to be 60. Then we encountered a 50, which is greater than the value we just pushed, which was 10, right? So we're going to add it. So we're going to add 50 now to our sum. So which will now become basically this operation, which will become 65. Now we kind of update our maximum sum with 65 and 60. So we see 65 is greater, so 65 is what our maximum sum now becomes. And if you see, this is what the answer that they provided us. So this is why we are returning a 65. Now let's try to do the same algorithm on this one. In this case, you see it's all going up. So we'll be starting with 0 initially, and our max sum will be 0. We encountered a 10, we add that, and we add that to our answer value, so 10, and then we update our maximum sum with 0. So 0 and 10, the maximum sum is now 10. The next value that we encounter is 20. The value that we just added was 10, and 20 is greater than 10, so we'll add that to our value. If it would have been less than 10, we would have set all this value so far to a 0 and then start afresh. Start with a 20 added to 0. Since that's not the case, we just added a 20. Now the answer becomes 30, and then we update our maximum sum between 10 and 30, the answer becomes 30. So now our maximum sum has been updated from a 10 to a 30. Let's move forward. We reached 30 now. Now 30 is what we are currently at. The value that we just pushed was 20, just pushed or just added was 20, and 30 is greater than that, so we are on an upward trend still. We add that to our answer. We add 30 to it. Now we add 60 total sum. We have to update that with our maximum sum. So this gets updated to 60. Now we are at 40. 40 is greater than the value that we just added, 30. So we add 40 now. So this becomes 60 and then plus 40, which is 100, and 160 gets updated now to 100. Then we reach down to 50. 50 is greater than the value that we just added, which is 40 right here. So it means we are still on a currently on a upward going trend. 50 gets added on this total sum, which is 150 now, and our maximum sum, which is 100 so far, gets updated now to a 150, and the loop ends. So this is why we are going to return 150 as the answer. Now let's try to do the same algorithm on this array that they have provided and see why the answer was 33. So let me erase all this really quickly, and then we'll start afresh. It's going to be the same approach. We're going to be only focusing on this array that they have provided, and we're going to do the same operation that we did. So far we are having our sum as maximum sum as 0, and the values that we encountered as 0. We reached at the 0th index, which is 12. We add 12 to the value, maximum sum gets updated to a 12. We move to the next value, which is 17. 17 is greater than the value that we just added to our answer, which is 12. So it means we are on an upward trend. So we add 17 to our answer now. It becomes 29, right? So our maximum sum gets updated to 29. So far the maximum sum that we obtained on an increasing trend is 29. Now things gets interesting. Now we reached 15. Since 15 is less than the value we just pushed or just added, which is 17, meaning we are going on a downward trend. What this means is whatever we have added so far in our answer will now all be diminished to a 0, right? We are not going to change the maximum sum. We are only going to diminish whatever we have added in our answer stack to a 0 and then start afresh. We set this to a 0 and then add 15 to it. So in this 0 we are going to add 15. So we are basically doing a new start. This right here is basically what we started from here, the same situation. We are starting from 15 now in the hopes that we are going to get higher values from here, but we'll realize that that's not the case. So 15 is what we have added. The maximum sum comparison is still going to happen. It still be 29. The next value is even lesser than that. We just added a 15 in our answer, and 13 is less than that. So this means this is also getting again diminished to a 0, and then in this diminished value 0 we are going to add 13. So 0 plus 13. So now we are at 13. We are starting with 13 in the hopes that we're going to find higher values from here on, but that would not be the case. And 13 is what we have so far. So again the comparison is being made with the maximum sum. It will still be a 29. So now let's move to the next value, which is 10. The value that we are at 10 and the value we just added 13. Since 10 is less than that, it means again this will get diminished to a 0, and then we add 10 to it, starting a fresh start. We add 10 to it. So our answer now is 10. We compare with the maximum sum, it's going to still be 10, still be 29. I mean, maximum sum is still remaining unchanged, which is 29. So from here on, in the hopes that we're going to have higher values, we are at 10. We reached 11 now. We saw that the value that we just added, 10, is less than the value that we are currently. So meaning we are in an upward trend. So we're going to add this value 11 to it. So now our answer becomes 21. And we're going to compare it with the maximum value, which is still going to be 29. The next value that we reached is 12. Now we are at 12. The value that we just added, is 11, and it is less than the value that we currently are, meaning we are on an upward streak. We are actually, if you see, we are 10, 11, 12, we are going up. So we add this to our answer stack or answer value. So basically this becomes this operation. This 2 are 21 plus 12. So this becomes now 33. So far on this upward trend, we realize that the sum of values is 33, and we compare it with our maximum value now, and this will get updated now to a 33, and this is what we return. So this is how the algorithm is going to work. We are going to simply iterate this value in the manner that I just showed, and the final time complexity for this one is going to be a linear one, and space complexity won't be much because we are not defining a list or a stack that we did in the previous question. Alright, so let's try to code this up now. So as we discussed, we're gonna need three variables initially. First will be the maximum sum value. Second variable with the sum value that we are in which we are gonna keep a track of the sum that we are adding, and third value will be the just added value. We need a variable in which we are gonna store the just added value. Why we need the just added value? So that when we encounter the next value, we will get to know if we are on a kind of going on an upward trend or a downward trend. If the just added value we don't have that, then how will we know that the next value that we encountered was a greater than value or a less than value? So there are going to be three variables all assigned to 0. First will be our, this is kind of our sum value where we'll be adding all the values while we are going forward. The second will be the maximum value. We are gonna keep a track of the maximum value obtained so far in this value. And the third variable will be a just added variable, meaning that if when we are reaching 17, for this 17 we need to know which value we previously added, so that we know if we are on upward trend or a downward trend. So these three variables we're gonna have to initialize initially. So that being sum value as 0, and then max value as 0, and then just added. These are the three variables we are starting with. So now we have to iterate this entire array. So for each value in nums, two possibilities are going to be happening. First is what if this value that we just encountered is greater than the just added value. So if that's the case, right, it means that we are on an upward trend. If that's the case, we are on an upward trend, we need to add this value to the sum value. Sum value will add this value. We are on an upward trend. And if that's not the case, it means we are starting on a diminishing trend or a going downward trend. In that case, we discuss what we're going to do. What we're going to do is diminish this entire sum value, whatever we have added so far, to a 0, and that becomes 0, and then in that 0 we're going to add the value at which we found the downward starting slope. So what I mean by that is, if you take a look here, we started from 12, we added 12 to our answer, just added value is 12. Now we came to a 17 is greater than the just added value, so we added to our answer, that's fine. But when we reach 15, we saw that we are going on a downward trend. When that happens, whatever we have added so far will be turned down to a 0, that's step 1, and in this 0 we will now add this 15 where we kind of saw the downward trend starting, in the hopes that from here onward, 15 onwards, we're going to find higher values. So that's why after this this sum value gets turned down to 0, we have to again add this value val to it, meaning this value is where the downward trend started. So this is what's happening sum wise. Then once these two steps are done, what we need to do is, firstly we need to update the just added value. This just added value will become value, meaning this is the value that we just added, no matter if it went on an upward trend or a downward trend. That's one. And then also we need to update the maximum value. Maximum value needs to be updated with the max value that we started with and whatever sum that we have so far, which is sum value. So once this is done, we just have to simply return the max value. So this is all the algorithm is, like literally like 10-15 lines of codes, less than 15 lines of codes. So if we try to run this now, you see it's satisfying all the test cases, and we'll submit this. So you can see it's beating almost all the solutions, and this is a linear time solution, because we are just iterating the values once and we are doing simple comparison. And if you see, this is exactly what we are doing in the algorithm as well, right? Because we are doing nothing but kind of iterating the values, and wherever there is an upward trend, meaning the value that we just added and the value that we currently are is greater, this right here indicates we are on an upward trend, and this else part is where the downward trend starts. If the downward trend starts, diminish all the value that we have so far to a 0 and add the current value at which the downward trend started. And whatever happens, the just added value has to be updated with each iteration, and every time we are iterating, we have to also keep an update of the maximum value that we have obtained so far. So that was it for today, everyone. I'll see you in the next one. Like and subscribe.